All right, so in this video, we're going to be talking about the probability of disjoint and overlapping sets. These are considered compound events, and we're going to talk about, well, what does each of those mean? So a disjoint means mutually exclusive. There are absolutely nothing in common. No outcomes are in common between these two events. And it's usually done with two, but you can have some more. Overlapping is when, obviously, what it sounds like, they overlap. They share some things. They have some events in common or outcomes in common with their two events. And what we're going to be taking a look at in class today is, well, how do we decide what is disjoint and what's overlapping? And we're going to start by looking at just a basic event here, the result of rolling a die and what's going to happen when you roll these dice. So the first is the result an even number? Is the result a prime number? Those are our two events we're looking into. So let's just list those. Now you can choose to either make a Venn diagram or you can list them out. It's completely up to you. So I'm just going to list them because we don't have that many. So event A, an even number, obviously, is 2, 4, and 6. Those are our even numbers on our dice. A prime number would be a number that's only factors are 1 in itself. So 2 is a prime number, 3 and 5. 4 is made up of 1 and 4, but also 2 and 2. 6 is made up of 1 and 6, and also 2 and 3. And when we look at this, you can clearly see that they share this rule of 2. So that means when I have to find the probability of these events happening, I have to make sure I don't double count that. And we're going to get into that a little bit later on. How do we make sure we don't count any duplicates? All right. And the next one, if the result is 2 or 4, obviously, numbers 2 and 4. An odd number would be 1, 3, and 5. And you can see there's clearly nothing overlapping in this point. 2 and 4, 1, 3, and 5, they're all clearly not part of each other's events. They're never going to overlap. So event A would be considered an overlapping event because they share something, and B are disjoint. They don't share anything at all. So that's how we decide whether things are overlapping or disjoint events. And we're going to work through a couple different examples using this and some activities finding all of that. But let's talk about these events. So first, the union is when you consider all of their events. So when we talk about the union, it's every single outcome. Whether they share it or not, it's every single outcome. The intersection is exactly what it sounds like. It is the overlapping part that they share. And then an intersection that's empty, we consider that a disjoint. Again, they share nothing in common. So we want to be aware of that terminology as we go through this. Oops. Okay, so compound event probability basically depends on if we're overlapping or not. If we're overlapping, then let me move this here. That means, like we saw in the dice problem, that 2 that they shared, we can't count it twice. We need to subtract out the duplicate so that way it's not overcompensated in our probability. So you'll notice that's the probability of event A plus the probability of event B, so the probability of each event happening, minus anything they share. Because if I take out what they share, I no longer have to worry about it being duplicated. The second one deals with a disjoint. Notice there is no subtraction because there is no overlap. There's nothing that they share, so I don't have to worry about subtracting it out. Some people will put -0 just to make things easier, so they're always doing something subtracting. It's completely up to you. But overlapping, we need to subtract it out. Disjoint, we're going to keep it without it, or you can subtract a 0 because they have nothing in common. Okay, and what we're going to be doing is working through using that probability. And you can see with the Venn diagrams where we can take note of whether they overlap or not. So obviously in part 1, I don't need to subtract anything. But in part 2, I'm going to have to subtract out this overlapping section. So this is using a Venn diagram. If you list them, then like I did in the beginning where I circled the 2 that the dice had in common, circle the common ones and subtract out however many they have in common. and that will make it easier for you as well. Okay. And again, we're going to go through a whole bunch of these problems, practicing, and it's going to end up building to be able to use multiple ways of probabilities. And I'm going to save that for a separate video, but hopefully you can at least get down those first ones like we had over here with this basic probability of our disjoint and our overlapping probabilities.